This video will introduce Weaviate, a vector search engine that brings the exciting advances in deep learning to user-friendly databases. Here's a quick overview of the presentation introducing the Weaviate Vector Search Engine. Each of these sections are highlighted as chapters that can be skipped ahead to in the YouTube Chapters interface at the bottom tab of the video. We'll start off with semantic similarity via vector distances, the origin of our interest in vector search engines. Deep neural networks process high-dimensional data and produce vector representations of them. Say you take in as input a 256 by 256 RGB image and eventually produce a 256-dimensional vector. You can now use that to query your database of images or text or audio or protein sequences, any kind of data, and find similar instances based on the vector distance with these representations that come from deep neural networks, like say the Hugging Face pre-trained transformers library. So say you have a picture of a cat and you want to find in your database a similar looking cat, you would compare the vector distances between representations of these cat images and you will have a similar picture of a cat. Then we'll talk about symbolic queries, the Achilles heel of deep learning systems. If you're trying to use solely deep learning for search, you'll miss out on the functionality that's been developed in these SQL relational database systems, this kind of style of using relations in order to truncate the searches and reduce the search space. So Weaviate combines symbolic search with vector search in order to take the advantage of these symbolic queries, things like filtering, aggregations, or say you only want to return text from articles that have been published in a publication such as the Financial Times. You can use that kind of filtering symbolic query to reduce the search space and then do the vector distance with your given query. So combining these semantic similarity searches with vector distances, utilizing symbolic queries through the GraphQL query language, and then combining these with the Weaviate interface. In addition to the exciting functionality of enabling vector and symbolic search, Weaviate Modules is also a very exciting integration to interface cutting-edge deep learning models that perform certain tasks. So for example, tasks in natural language processing include question answering models such as question answering models trained on Squad or whichever dataset that you're personally working with and want to integrate within your vector search engine. And there are also tasks like natural language inference, duplicate question detection, duplicate text detection, named entity recognition, fact verification, to give a few examples in natural language processing. In images, we have things like image classification, object detection, semantic segmentation, and then you have multimodal vision language like visual question answering, image captioning, and so on. Weaviate Modules is how you interface these deep neural networks that perform tasks on top of the vector and symbolic search. So you can return instances from your database that match this vector and symbolic query, and then you can process the returned data with your task models. A really exciting part of Weaviate is the Weaviate Modules that lets you integrate this functionality to your vector and symbolic search engine. Then we'll look at the demo dataset that's available when you're first starting out with Weaviate and then learning how to use this GraphQL interface. And I'll be making a separate video shortly that looks through 8 different demo queries with the GraphQL language that shows how to do this vector and symbolic search with a hands-on example. The demo dataset currently contains news articles that have been published in given publications like the Financial Times or the Wall Street Journal, as well as the authors who have published these articles. CEO Bob Van Light has recently announced the integration of Wikipedia into this demo dataset, so you can instantly access Wikipedia and query it with the GraphQL language on top of Weaviate with the vector searches as well that have been encoded with Hugging Face transformers, and you'll be able to do this all in the demo. But here are some additional ideas that we're working on with Weaviate in collaboration with Henry AI Labs. First of which would be a cool integration project with Hugging Face datasets. So currently we have a Streamlit interface on Hugging Face datasets where you can quickly browse and say almost do like a pandas data frame.head to see the first given rows of the datasets in the Hugging Face datasets, but we think it would be really cool to integrate Weaviate with the Hugging Face dataset endpoints or the papers with code, papers with data endpoints, so that you can not only just preview the first 5 rows of these datasets, but you can do vector and symbolic search with these datasets on these public endpoints. So that's an integration project that I think is really exciting, and I'm really excited to also announce a dataset that I've been working on in one of my first publications in my research career. And then I want to discuss further some research ideas that I think are made possible with the Weaviate Vector Search Engine. Areas like generally just looking through these big self-supervised language modeling datasets, and then ideas like the image to text search, ideas like CLIP and VQGAN, how people are using that to generate images and what we can do with that with a vector search engine, which would dramatically facilitate trying to find the image that matches the text query. And then also the really exciting idea of retrieval augmented generation and recent papers from Facebook AI, such as internet augmented generation. We could imagine using the Python client in Weaviate to append that to our language models and let our language models use the Weaviate vector and symbolic search to query their external knowledge, their documents, in order to fetch context for the current language modeling task. So this is an overview of the presentation of the introduction to Weaviate. As a reminder, these are all outlined as chapters in the bottom interface of the YouTube video if you want to skip ahead to the section that interests you most. The idea behind vector similarity search based on deep learning is that deep neural networks produce dense semantic representations of high-dimensional data. So this is the AlexNet paper in 2012 that takes in as input a 224 by 224 RGB image, processes it with layers of convolution and max pooling, and eventually produces these vector representations. In this case, the vector representations in AlexNet have the dimensionality of 2048. Papers like SimCLR, MoCo, these contrastive self-supervised learning algorithms are particularly optimized to produce these semantic vectors of similarity between data, and it can learn from unlabeled data just using data augmentation in order to produce these kind of vector representations. So we compare semantic distance between two different data objects by looping through these vectors in a naive L1 distance, L2 distance style, where we say have vector 1 at 0 minus vector 2 at 0 squared plus vector 1 at 1, vector 2 at 1 squared, and so on as we calculate, say, the L1 or L2 distance between two vectors. So we can compute vector distance. It could be other ways of computing the distance, but this is how we're going to compute the distance between vectors to determine semantic similarity between two high-dimensional input data objects. These could be videos, images, audio, protein sequences, and so on, all of these different kinds of data that are represented as high-dimensional objects. And even most of these, say, tabular data or categorical data, you would encode it into a continuous embedding space, and then that's kind of your high-dimensional representation that gets processed into these vector representations. So naturally, it's not the best idea to try to brute force the similarity search with every other vector and do that L1, L2 distance comparison with every single vector in a database that could have, say, 30 million images in it, or say a billion different sentences in it for text datasets. So you could parallelize this with GPUs and really distribute the similarity comparison, but a better idea is to build an index and have centroids that represent nearby vectors. And Bob Van Light had a great example of this. Imagine you're going through a grocery store and you're looking for an apple. First, it would be good to just know where the fruit section is. So this is kind of the way of thinking about navigating these vector indexes and having centroids that represent semantic concepts. And then once you find kind of the neighborhood of the fruit section of the grocery store, now you can better find fruit, I meant the apple, compared to just looking at the entire grocery store. So the overall index that is used to build up this the centroids and facilitate the speed of vector distance search is the hierarchical small world graphs. And I'm not really navigable small world graphs, sorry, I missed that in the slide, but I won't really get into the algorithm of this yet, but this is one of the cutting edge algorithms that are being used to speed up vector distance search. Comparing vector distances from representations produced by deep neural networks is great at finding semantic neighbors, but it's missing on some of the key functionalities enabled in symbolic querying systems. So I've been really excited about recent papers in deep learning like neural databases or database reasoning over text that are combining the functionality of symbolic queries with deep learning systems, and particularly deep natural language processing systems is a common area to study this in. So you already have these massive text data sets. So you might want to filter them based on symbolic queries like where they were published. So say as I look through deep learning research papers and I'm trying to find papers in the ICLR 2020 publication that mention data augmentation. Instead of searching for data augmentation in the vector distance with the entire corpus of all the deep learning papers that have been published in, say, 2014 to 2022, another example of a symbolic query you can use is filtering it down by the data it was published in, but you can use these symbolic filters to dramatically reduce the vector space, and then your HNSW tree is going to be more accurate, your vector distance, everything's going to be more accurate by filtering down the search by using these symbolic filters. And the symbolic filters are enabled in Weaviate by not only storing the vector representations in the database, but also storing the data objects. So you have the class property schema that's used in these GraphQL interfaces of linking objects between each other. If, say, you have in the demo dataset example, you have news articles, you have publications, and you also have authors. GraphQL is great for linking together these different kinds of objects, but we'll get into that more later on in a separate video, solely looking at the GraphQL interface. But what's important to take away from this slide is this idea of using symbolic queries to filter down the vectors that you need to search through and overall facilitate and add this functionality of symbolic querying to vector neural search. This video from the Semi-Technologies YouTube channel is illustrating how to combine vector searches with the symbolic filtering in the GraphQL interface of Weaviate. You have the concepts of prices of houses, which is being used for the semantic search of finding articles that are discussing the prices of houses. Then you have the symbolic query part of it that's saying that it must be published in the Financial Times publication. You can also see how you can stack together two different symbolic queries. So it has to be published in the Financial Times, and the word count of the article has to be greater than the given value, so you don't have short articles. These are examples of the symbolic queries, such as the comparison of the word count and so on, ideas that can be used in Weaviate. Now let's dive into the Weaviate Modules section, and this is a very exciting part of Weaviate that lets you append these deep learning specific task solvers. So say you have a question answering system, a fact verification system, and you want to take these task solving models and wrap them into a user interface that lets you do database querying to fetch the context where the inferences are produced from, as well as these models that have been trained to perform a specific task. So say you want to do fact verification for medical literature, you retrieve the medical literature with the vector search engine and the symbolic queries, and then you can use on this layer on top of that, the fact verification model that processes the return context from the vector search engine. So here are some of the currently available Weaviate modules. You have this tree that describes what's available. So for the sake of vectorizing the data, you have the text-to-vec contextuary, things like glove embeddings, the glove word embeddings, and then you have the transformers, where you can integrate any transformer model. You have things like Distilbert, BERT-based encased, Roberta, and ideas like this. Then you have these models that are trained to produce vector representations of text. So you have things like Semantic Similarity, Cora question pairs, paraphrasing, and I think the MS Marco is a query document similarity comparison. These are all examples of natural language processing tasks where the idea is to compare the query with the context. So say in Cora duplicate question pairs, you have two questions, so the representations are really good at contrasting between these semantic neighbors. So these representations are great. The sentence transformers from Hugging Face are great for semantic distance, and they can be really fine-grained with things like Cora and the paraphrase detection and so on. So then you have multilingual models, and then you have an interface to add any custom Hugging Face transformer. So whatever you're working with, you can upload your model to the Hugging Face Model Hub, and then you can access it through Weaviate text-to-vec transformers, custom, and then the path to your Hugging Face model. And this is how you vectorize data in the database. Then you have the way that you can vectorize images. So you have the ResNet 50, ResNet 50 PyTorch are currently integrated. Say you're using something like OpenAI's CLIP model, you would just have the custom, the text encoding of CLIP, and then you have the image encoding of the ResNet that's been trained with the CLIP law. So you'd have these two different modules, and that's something that is also being worked to add to Weaviate, is these the CLIP style search between text and images. So now you have the supervised learning tasks these models have been specialized on. So you have question answering, things like that have been trained on the SQUAD, the Stanford Question Answering Dataset is one of the most common datasets for training extractive question answering models, where they don't generate an answer to the question, rather they classify where the answer might be in the return context. Then you have named entity recognition, spell checking, and the opportunity to add any custom module. So this is the Weaviate Modules ecosystem, the tree that currently describes what's available, and this will be a really exciting trend to keep an eye on in the future development of Weaviate. Here's a video from the Semi-Technologies YouTube channel that's showing how to use the question answering module on top of the vector search engine. You're asking the question, what was the monkey in the Neuralink video doing? And then you're passing in the properties for where to look for the answer to this question. So now when you query the class property structure of these publications, it knows how to index the publication into the summary property. As you see, you have title, summary, publication date, and use that in order to find the answer to the question using the SQUAD pre-trained model in the Hugging Face Transformers library. This is the Weaviate console to practice out different GraphQL queries and get familiar with the GraphQL syntax for learning how to use these vector and symbolic searches to search through different databases. So what you're seeing is the demo data set of the news articles and publications for getting started with Weaviate that's hosted at this endpoint. And as mentioned, Wikipedia will be added to this soon. And overall, this idea, I think you could add any Hugging Face data set that's in that Hugging Face datasets library, or say Kaggle datasets or papers with code, papers with data, and put this kind of interface on top of those endpoints. So you have these endpoints, and then you have the schema for each of these data sets. Then you can access them in the query console rather than, say, the Streamlit interface for doing this kind of vector search engine to get more of a sense of these data sets that you're working with and do semantic searches with them. So anyways, so this is the demo data set, and this is an example of using the semantic vector search, the concept of ride sharing. So it's going to use the vector representations to find articles about ride sharing, and then you're using the symbolic queries where it has to have a word count greater than 200. As you see the return articles, 1,300, 500 words plus. And then it's also looking for this value string in like the regular expression matching with taxis. So it's looking for tax. So you have flying taxis are about to take off at last. Can bike taxis really compete with Uber? So this is the GraphQL console demo that you can find in the Weaviate documentation to practice with these different GraphQL queries and understand how to do these kind of searches. So to build on this, here's an idea that I think would be really exciting for Weaviate and overall the deep learning ecosystem of developing these models and developing these datasets and benchmarks. So Hugging Face datasets allows anyone to upload their datasets onto this public hub of datasets where you see you have the glue benchmark, the squad question answering dataset as mentioned several times in the video, the IMDb text classification dataset, and they're even adding image datasets to this as well. As you see, they have things like, it's not on the side left panel here, but you have, say, CFAR10 is also accessible in the Hugging Face datasets interface, and it's really easy to just do pip install datasets, from datasets import load dataset, and then dataset equals load dataset, Winogrand or whatever, to access these datasets in your Python workflows. So we have Hugging Face, this collection of datasets, and it'd be really cool to be able to click on a dataset and then have the option to explore the dataset with the Weaviate console to do this vector search. And we have many other examples of collections of datasets, papers with code, and then say also the Kaggle datasets, and adding this layer of the vector search engine onto this is something that I think could be really exciting. Here are some of the research ideas that I have for integrating Weaviate with my deep learning PhD research. The first of which is to explore these big language corpora for self-supervised language modeling. So we're scraping these massive text datasets from the internet that we're using to do language modeling, and it would be really nice to have this kind of vector search to get a better sense of what's in these massive datasets, because obviously you can't manually look through it all. And then particularly I've been working on this project. I'm really excited to announce this soon. Keras BERT, it's a language model trained on everything I could find on the internet about Keras, and then trying to use it as a code helper similar to OpenAI's Codex, but even say a little more specific than Codex because it's trained on only Keras code. And this idea of self-supervised language modeling with code datasets and semantic code search is how I see the vector search engine part of this playing into it. I think this is a really exciting way to use these vector search engines to better build these deep learning tools for writing deep learning code. And I love the recursion of that. I think it's hilarious. So it's also really cool to building AI, and things like looking at deep learning research papers and the scientific literature mining stuff. Obviously big interest around, say, data sets like Cord19 and all the biomedical corpora and so on. So also really excited about text-to-image search databases. So we've seen things like all over Twitter, Clip VQGAN. We have things like a banana performing stand-up comedy or the avocado-shaped armchair. These kinds of ideas of combining text embeddings with image embeddings and then using an image generation model to produce the images that you then search through with the vector distance comparison, and using this to produce images. And overall, I think text-to-image searching can be a really exciting tool for these vector searches and a really exciting next generation of our image search engines. Say things like Unsplash, where you may go to find an image for your presentation or whatever, a better kind of interface of using the text to search through all the different photographs on Unsplash to find something that matches your presentation or whatever you're doing. So then also I'm really excited about this research in retrieval augmented generation and retrieval models and Facebook AI's recent internet augmented generation. These kind of models benefit enormously from context, these kind of language models, language generation models. So this research into how you fetch the context to strengthen these language models is really exciting. And Weaviate has this Python client interface that a language model could use. A language model could access the vector search engine through the Weaviate interface, and then the language model could learn to use Weaviate to fetch its context, and it can use the vector and symbolic searches, which I really don't think there's anything out there that has that kind of functionality with a language model's context retrieval system. And then also prompting, where say GPT-3 fetches examples, maybe you could use some kind of vector search to find the nearby examples, and then we have all these kind of databases of thinking about prompting. So it's really exciting is overall this idea of having this more dynamic system of using contextual embeddings for whatever application it might be. It could be e-commerce recommendation, any kind of idea of having this dynamically adjusting vector search index, and then also again the Weaviate modules you can stack on together, say classification models and so on within this interface. So overall, here are some research ideas that I'm working on, and overall really excited about this Weaviate tool. Hopefully this video inspired your interest in using the Weaviate Vector Search Engine. If you want just my 2 cents on your personal idea for a use case or project idea, you can leave a comment on this video. You can also go to the Weaviate Slack channel where CEO Bob Van Lloyd or somebody else on the Weaviate team will answer your question about your use case, or again, give you like the 2 cents on what they think about your project idea. And you can also connect with me on Twitter at cshorten30 if you want to shoot me your use case for Weaviate and just see if I have anything to contribute to it. So if you're interested in learning more right now, I recommend checking out my podcast with Eddie and Dillacher, the CTO of Weaviate, and we had a great conversation about a lot of these topics that have been mentioned in this video. And I also highly recommend going through this Introduction to Weaviate Vector Search Engine by CEO Bob Van Lloyd, about the going through different ideas like the GraphQL language, the Weaviate Modules, and so on. A really great overview, 9 minutes of your time to get a better sense of Weaviate, and this was a video that really helped me a lot in learning about this as well. And it's please subscribe to the Semi Technologies YouTube channel. They have great videos on, I think it's something like 15 videos uploaded right now. They're uploading their meetups as they announce new features and so on. So I highly recommend checking this out as well if you're interested in this Weaviate Vector Search Engine. So finally, if you're interested in learning more right now, I highly recommend checking out the Weaviate documentation. This is an extremely organized set of documentation, getting started, quick start, and installation of Weaviate, the architecture of the vector search engine, setting it up for your own use case where you pass in the modules you want to use and so on, these different kinds of ideas, the HNSW algorithm, the modules that you append with the vectorization and so on, the client libraries for integrating this with Python and accessing your database, understanding the data schema, understanding their RESTful API as well as the GraphQL API, and then different tutorials. So I'm quickly going to be, pretty soon going to be releasing a video on the GraphQL demos in this, but I highly recommend checking this out. This is a great documentation of Weaviate. Thank you so much for watching this introduction to the Weaviate Vector Search Engine. Please subscribe to Henry AI Labs for more deep learning and AI videos, and please stay tuned for more content about the Weaviate Vector Search Engine.